Hey there, and welcome to today's Explainer. Look, we are stepping firmly out of the classroom right now, moving way beyond those basic textbook wizard walkthroughs. I'm putting on my senior administrator hat here because we're entering the high-stakes reality of enterprise IT. You know, in a lab, a bad domain controller deployment just means you hit reset and start over. But out in the real world, bad deployments cost organizations dearly. They bring down critical systems and can literally burn through hundreds of thousands of dollars. So, we're going to look closely at the exact critical decisions you absolutely need to make during deployment to ensure your infrastructure is rock solid. Okay, let's dive into this training blueprint. We're going to follow a very specific, logical path today to get you deploying safely. First, architecture and DC types. Then, safe promotion and disk settings. We'll move on to preventing WAN link saturation, followed by RODC branch office security, and we'll wrap the whole thing up with certificates and time sync. This is your guide to doing it right every single time without triggering a catastrophe. All right, Section 1, Architecture and DC Types. Let's build our foundational toolkit. Before we even think about running a deployment script, we've got to know our tools. We've got 4 specific options in our domain controller toolkit, and understanding when to use each one is step 1 of any architectural plan. First up, the standard writable domain controller. This holds a full read-write replica of the NTDS.dit database. It's your go-to for a secure, on-premises data center. Second is the RODC, or read-only domain controller. You use this exactly where physical security just can't be guaranteed, like a retail branch office or out on a factory floor. Third is the Azure IaaS DC, which gives you that crucial cloud authentication resilience for your hosted workloads. And finally, Server Core. This is the headless, no GUI installation, which honestly should be your recommended default. And this brilliantly illustrates why we push Server Core so hard. When you compare Server Core directly against the full desktop experience, the difference in risk is just massive. With Server Core, you've got this headless system with a significantly smaller attack surface, plus it requires way fewer patches. On the flip side, the full desktop experience just drags in all this unnecessary GUI overhead and gives attackers a much larger target. When you're building out an environment, prioritizing Server Core is exactly how you proactively shrink those vulnerabilities right out of the gate. Let's move to Section 2 and see how this builds into safe promotion and disk settings. These are your absolute rules of engagement. Now that our architecture is mapped out, let's talk promotion. You're basically looking at 2 main commands here. You'll run install ADDS exactly once per organization when you're building a brand new environment from scratch. But the workhorse command, the one you'll use dozens of times in your career to add redundancy or expand to new sites, is install AZ-800 Domain Controller. Now here is a non-negotiable rule from me to you. You must absolutely mandate that the database path and sysvol path parameters map to dedicated data disks. Never, and I mean never, point these to your OS drive. And listen, if you're deploying in the cloud, there is a specific fatal trap just waiting to spring on you. On Azure virtual machines, that dedicated data disk holding your database must have its host caching explicitly set to none. If you forget to disable write-back caching on a DC disk, a sudden, unexpected shutdown can instantly corrupt your NTDS.dit database. It's such a tiny setting, but man, it causes massive destruction if you miss it. Speaking of destruction, let me give you a senior admin warning that will save you hours of absolute misery. Do not ever forcefully format or permanently shut down a domain controller without formally demoting it first. If you just wipe a DC, you're going to leave all these ghost records floating around an Active Directory, which leads to an incredibly painful recovery nightmare known as metadata cleanup. If you do get forced into an emergency cleanup checklist, you're stuck manually clearing out AD sites and services, hunting down and deleting ghost DNS SRV records, and carefully running the NTDS util command line tool. Save yourself the headache. Always demote by the book. Okay, Section 3, Preventing WAN link saturation. Let's look at a real-world disaster. I want to share a story about a global bank in Singapore. 18. That number right there represents 18 gigabytes of NTDS.dit data. An engineer in Singapore needed to add a new domain controller, but they missed one tiny, critical step during promotion. They didn't specify a local replication source. Because of that, Active Directory just automatically picked Frankfurt as the source. So, 18 gigabytes of data started mistakenly replicating at an absolute crawl across a slow international WAN link. 6. That is how many hours the international WAN link was completely saturated. For 6 solid hours, this single oversight choked the bank's trading systems. It was an incredibly simple mistake that ended up costing the organization hundreds of thousands of dollars in business impact.
So, the crucial point is how easily this whole disaster could have been avoided using IFM or install for media. Whenever you're deploying across a slow link, you start by generating a local snapshot on the nearest existing DC. Then you transfer that snapshot using physical media over to the new site. Finally, you promote the new DC using the installation media path parameter. By doing this, only the delta changes, just those tiny little differences made since the snapshot was taken, have to actually replicate over the WAN. You literally drop your replication traffic from gigabytes down to megabytes. In large enterprise environments, IFM isn't just an option, it is standard practice.
Moving right along to Section 4, RODC Branch Office Security. Let's talk physical security risks. Imagine a physical server gets stolen overnight from a retail store. If the stolen server is an RODC, IT runs a credential exposure report, sees that maybe 47 local user accounts were cached, resets those passwords, and deletes the computer account. Bam! It's a 22-minute fix with zero domain-wide compromise. But what if a writable domain controller had been stolen from that exact same insecure location? Now you're in a multi-day crisis. Every single user's credentials in the entire domain are at risk. You're looking at a mandatory double forest-wide Kerberos TGT password reset to invalidate every Kerberos ticket in existence, not to mention all the regulatory notifications. Placing an RODC in an insecure location isn't a preference. It is the absolute difference between a minor 22-minute annoyance and a catastrophic multi-day breach. But to make that RODC architecture actually work securely, you have to nail your password replication policy. The best practices here are really strict. First, you only cache the required local users for that specific branch. Second, you actively audit privileged accounts to see who is trying to access what. And most importantly, you strictly deny all replicated privileged credentials. You've got to ensure that enterprise admin credentials are never, ever left sitting around on a server in a branch office. Finally, Section 5, Certificates and Time Sync. These are the silent killers. Let's map out the symptoms of massive, simultaneous authentication failures so you know exactly what you're looking at. When your LDAP certificate on port 636 expires, every application querying AD securely is going to fail simultaneously, and they'll throw these incredibly vague errors. When your Kerberos certificate expires, smart card logins will instantly break. Your daily or weekly diagnostic routine shouldn't be about guessing. Make it a scheduled task to check both of these by running the PowerShell command get-child item cert/localmachine/my sorted by not after on each domain controller. That way, you know exactly when they expire before it actually becomes a problem. Now, if you are actively facing these authentication failures right now, you're in an emergency management scenario. The immediate remediation step is to ensure you have auto-enrollment configured via a group policy object that points to your enterprise CA. If you make changes and need to force an immediate update to bring those authentication services back online fast, you drop into the command line and run certitool-pulse. Now, what's really interesting about this next topic is how often it trips people up. What do you think happens when Azure domain controllers are left to sync their time with the underlying hypervisor host? Total Kerberos authentication failure. If those Azure DCs sync to the host, they will inevitably drift and diverge from your domain's strict time hierarchy. The operational necessity here is that you absolutely must explicitly disable the Azure hypervisor time sync service. Instead, you manually point that cloud domain controller back to the on-prem PDC emulator for its time. Keeping your cloud time perfectly synchronized with your domain hierarchy is the literally only way to prevent Kerberos failures for your Azure workloads. So we've covered the strict architecture rules, the critical disk and promotion parameters, how to optimize those WAN links, and the silent traps of certificates and time sync. To maintain all this, you really need to categorize and organize your tasks. Schedule weekly audits of your password replication policies, implement daily monitoring for those LDPS certificates, and always have an emergency management checklist ready to go for FSMO seizures or metadata cleanup. So to wrap this explainer up and leave you with something to think about, have you ever had to do an emergency FSMO RODCs or deal with a completely failed domain controller? Understanding what we covered today ensures that when that disaster does strike, you'll know exactly how to handle it. Thanks for tuning in.